Hello and welcome to Preparing for SAP Deployments in IBM Power Virtual Servers in IBM Cloud. My name is Mike Friesenegger. I am a solutions architect working on the global IBM partnership. This means I get to work with many different groups in IBM. This session pertains to my work with the IBM Power Systems and IBM Cloud teams. There are 3 agenda items for this session. The first, introducing IBM Power Systems virtual servers running on IBM Cloud. The second, deploying SUSE Linux Enterprise on IBM Power VS infrastructure. And the third, a sneak peek at automating the deployment. I've tried throughout this presentation to add hyperlinks to the documentation and other important things if you have future plans to try what you see in this session. So now let's dive into introducing you to IBM Power Systems virtual servers running on IBM Cloud. I want to give a short background about running SAP workloads in IBM Cloud. There are several compute options where SAP workloads can be run. IBM Cloud bare metal servers are fully dedicated servers providing maximum performance. They are secure and single-tenant deployments. SAP HANA certified bare metal systems were first released as infrastructure as a service by IBM Cloud in early 2017. The IBM Cloud Virtual Server for VPC provides the security of a private cloud with the agility of a public cloud using protected space. This is IBM Cloud's latest environment and network with the newest technologies and networking capabilities. Classic provides public, dedicated, reserved, and transient virtual servers. This is the original environment and network, formerly known as the soft layer network. These first 3 support SAP workloads running on SAP certified Intel systems and virtual machines. The final compute option is IBM Power Virtual Server, also known as Power VS. This environment is maintained by IBM Power Systems and built of IBM Power Enterprise components. It has links to the classic infrastructure as well as the VPC infrastructures. A myriad of SAP workloads are supported on IBM Cloud. In the data centers, the Power Systems virtual servers are separated from the rest of IBM Cloud servers by separate networks and direct attached storage. This infrastructure design enables Power Virtual Servers to maintain key enterprise software certifications and support, as its architecture is identical to certified on-premise infrastructure. The internal networks are fenced, but have connectivity options to the rest of the environments and services on IBM Cloud. There are several ways to interact and manage IBM Power Virtual Servers. We will review several of these in the coming slides. Some basic terminology is important to understand. Power VS services are per geographic region and data center. One Power VS service in a region or data center can host multiple Power VS instances, which are also known as LPARs. So for example, you can have 2 Power Systems virtual server services, one in Dallas, Texas, and another in Washington, D.C. Each service can contain multiple Power System virtual or Power VS instances. Power virtual servers can be created in the Americas, Europe, and Asia-Pac. This link will give you more details about the regions and availability zones. Here is some information about the compute, storage, and networking components. There are 48 certified Power VS profiles for SAP HANA that give customers choices based on their SAP workload requirements. For example, the Power VS compute options include being able to run on IBM Power System E880 or an IBM Power System S922, Also, an IBM Power System E980. Now, some of the options are only available in certain data centers, so be sure to look at the links that I've provided on this page. There are dedicated and shared processor options. The dedicated processors are priced the highest as they provide the best overall performance. Shared capped processors cost slightly more than shared uncapped processors because of their flexibility in addressing licensing restrictions. Power systems processors and memory options include, for example, on the EA80, it can provision up to 143 processors and up to 7.5 terabytes of memory. For the E980, it can provision up to 143 processors and up to just over 15 terabytes. In the interest of time, I'm not going to go into details about the storage and the networking, but you are welcome to look at the hardware specifications link on this page. For SUSE Linux Enterprise Server on IBM Power VS running in IBM Cloud, customers will need to bring their own SUSE subscriptions to activate and receive patches. We understand that this is not optimal for some customers, and SUSE is working with the IBM Power and Cloud teams with the goal to provide pay-as-you-go options as well. Today, SUSE Linux Enterprise Server for SAP applications 12 SP4 is available as an image in IBM Cloud. I am working with the IBM Cloud image building team to provide more SLES and SLES for SAP image options. Both SLE 12 and 15 are supported in the Power VS infrastructure. Please be aware of the minimum levels if you decide to bring your own image. Manual installations and Kiwi-based image builds are the preferred options for bringing your own image. An IBM specific cloud init is required, so make sure you're aware of that. And then lastly, there are a couple of ways to capture an image with on-prem Power Systems hardware if you have access to it. If you have access to a Power VC environment or to a VIOS server, then you're able to capture those images locally and upload those to IBM Cloud. Now let's talk about the ways to interact with IBM Cloud to deploy SUSE Linux Enterprise on the Power VS infrastructure. I want to provide links to the best practice documentation, so please review these documents as you plan your SUSE Linux Enterprise deployments on Power VS systems within IBM Cloud. One way to interact with IBM Cloud is by using the web interface. In the upper left picture, it shows a Power VS service named SUSE Power VS and connected to the London 06 data center. You can see two Power VS instances, SUSE-HANA 01 and NFS, that are running in this data center. The lower right picture is after I clicked Create Instance. Here you can see that I selected the SLES for SAP 12 SP4 image that will be deployed on Tier 1 storage. I mentioned the 48 selectable profiles previously. I have selected the only non-prod option, but I'm being told that this option is not possible with the E980 hardware that I've selected. So I'll need to change this to a 922 base system to use the non-prod option. We see a couple of examples using the IBM Cloud CLI. The CLI requires plugins that add functionality. There is a PI, or Power Infrastructure plugin, that needs to be added so the CLI can interact with Power Virtual Server. The screenshot on the left shows instances and volumes that are deployed in the London 06 data center. The screenshot on the right shows the list of available Power VS profiles that can be chosen depending on the SAP workload requirements. Now to the demo. This demo will show Terraform and Salt being used to deploy 2 Power VS instances. With one command, the instances, the storage, the networking, the SLES for SAP image, HANA, HANA system replication, and the SUSE Linux Enterprise HA extension with the SAP HANA SR resource agent are all deployed or installed and configured. We've adapted for Power VS what our SUSE engineering team has published via the HA-SAP-Terraform-Deployments GitHub project. The link to the GitHub project is above. The Power VS branch is a work in progress, which you can follow in GitHub. The automation took a little over 59 minutes, but I'm not going to take 59 minutes to show you the demonstration. Actually, the demo video that I will show has been shortened to about 3 minutes and 30 seconds. So let's cut over to the demonstration. All right, so what you're looking at here is the IBM Cloud web interface in the background, and I'm connected to the SUSE Power VS service that's attached to the London 06 data center. On the front terminal window, I'm actually in the Power VS directory of the HA-SAP-Terraform deployments project on my local machine. I'm going to kick off the Terraform apply command, and it's going to go ahead and start the process of the deployment after I answer yes. 21 resources are going to be deployed, and as the deployment starts to happen, you can see in the background on the web interface, volumes are being created. To speed things up, now you can see that the HANA instances are being created, and in this case, they're labeled default-HANA 01 and HANA 02. Now we're going pretty fast here, and as you can see, would normally been about 8 minutes of waiting at this point. The HANA instance, the first HANA instance, the 0 instance has already been created. The second HANA instance is still in the creating state, so we're still waiting for that to be finished before Terraform moves on to the next step. And now the second instance is created, and now Terraform starts working on connecting to the systems and kicking off Salt. And now Salt is in the process of connecting to the systems, patching the systems, basically doing a lot of setup-based work in preparation for the HANA-based install. The systems get rebooted, and Salt picks back up. Terraform tells Salt to pick back up, and now it's actually in the provisioning stage. And here in a moment, it's going to start installing HANA. But before it starts installing HANA, it has to actually format and mount the file systems. And you saw that a moment ago. Now it's actually going ahead and extracting the HANA media and starting the HANA installation. Now the HANA installation takes a little bit. This is happening on both systems at the same time. Now the installation is complete, and now HANA system replication is being enabled, making the first system, HANA 0 or HANA 01, be the primary, and HANA 02 will become the secondary. So HANA system replication is installed, and the first system is complete. The HA was all set up and everything. It happened very quickly, but I just don't want to waste a lot of your time watching screens go by. The second system is now entering the cluster, and it just completed, and the automation is done at this point. Now let's flip over to the web interface, and you can see HANA 01 and HANA 02 are configured. There's IP addresses associated with them, and we're now looking at the storage, and you can see all of the storage devices that were created as part of the automation. So, like I said, this automation took a little over 59 minutes. I cut it down to 3 minutes and 30 seconds just to show you and give you a little bit of how this works on the back end. I'd love for you to follow along the project in GitHub and test it out and provide comments if you'd like. And with that, I'd like to thank you for your time, and I look forward to any questions that you might have about this presentation and about the automation. Thank you very much, and have a good day.